Big Yellow Self-Storage is in fact a developer, an operator and an owner of self-storage, and it's a real estate investment trust also. So we do have a long-term interest in the building portfolio and its value. Firstly, moving on to my role in the company. As CSR manager, I've got to get together a policy and a committee. And that committee consists of the planning department, design, the construction company as well within Big Yellow, which obviously has the finance to put the buildings together, and which I depend on a certain percentage of that finance to make these buildings green. But this, as mentioned before in a previous presentation, you have to pass the knowledge on from the design and the development and construction onto facilities management and also the operation of the stores and the behaviour within the stores by the store staff in things like energy efficiency checks. And also there is a retail function and a marketing function, and also that helps us to communicate what we are doing externally to our customers and other stakeholders as well, such as investors. I think the first thing I want to get across is what is self-storage, because the actual function of the people and the building are important in the energy demands that we have and the type of technologies that we actually choose. In fact, it's quite critical. So you can see that we have business customers and also domestic customers. And it's all about the demand for space when you're expanding a business or the business load becomes greater and you require more space than the building you exist in. Or on the domestic scale, it's about lifetime events such as deaths, births and marriages, or moving up and down the housing scale or ladder. You do need somewhere to store extra goods. So looking at the building, you can see that 97% of the building is storage area, of course, and most of this is a modern method of construction, or relatively modern. Good solid insulation, precision built cladding so that there's, everything fits together very well, and there's a lack of leakage within the building. So we call that building relatively passive, not in the sense of a passive house, but fairly good in retaining heat. And on the ground floor we have a concrete slab. Although it's got a very high embodied energy, it does absorb and release heat at the correct times of the day or the seasons of the year. You can see from this picture that there are no windows in this part of the building, which is 97% of the area. That is because ultraviolet light does have an impact on people's valuables and goods. So we do need a high lighting demand during the daytime and throughout the year as well. The flooring you can see here is a particle board, which is about 80 to 100% recycled sawdust and bark from trees. The partitioning is steel. It's a thin steel, so it's not very strong. That ranges from about 40 to 60% recycled content. The breeze blocks are secondary aggregates or byproducts from industry. So they're recycled pulverized fuel ash. And also the insulation is just recycled slag from the iron smelting industry. So the materials that we're using are quite low embodied energy and quite a high recycled content. Only 3% of the area of the building is requires heating and cooling. That's the reception area, and it's occupied public space by our staff and our customers. So you can see the demand for energy has quite a different profile from the housing sector and offices as well. There is a significant demand from elevators, but not while the stores are immature. In other words, when they're not occupied by customers, there's not many people going up and down at different levels. But as soon as the store reaches about 80%, 90% occupancy, then the demand increases. We also have about 10 flexi offices attached to the self-storage units, which offers another dimension to businesses that want to expand. Unfortunately, 8 of these are gas heated for heating purposes, and we've normally inherited these gas-powered systems. And unfortunately, any type of combustion doesn't really fit in well with the self-storage or model at all because of the threat of fire. So the store portfolio consists of 62 stores. We normally build about 6 stores a year. At the moment, that's dropped down to 3 stores a year because of the recession. And the store can be divided. The store portfolio can be divided into 3 separate areas of about 20 stores each. The early ones being refurbished, so there's quite a good improvement in insulation and airtightness in these buildings. The second phase of stores were relatively modern methods of construction, and then the last 17 stores that we've built have always had some kind of green building aspect. So we called these the eco stores. The first store here that we're showing is a refurbished store. This is an old fossil fuel power station in Fulham in South London. And it's got about a 20% renewable energy input from a large solar panel on the roof, and also a green roof as well. So in effect, we're now generating renewable energy from the former power station. This is not a very typical modern method of construction, but we do have planning actually required us to put some apartments in around part of the store itself, so that's adding a bit of insulation to the building, which doesn't require any heating or cooling in that sector. And then finally, the what we call the eco stores. This is one in Merton in South London. It has a Quiet Revolution wind turbine, and a solar panel can just be seen to the bottom left-hand corner on the roof there. And it also has some costs which you can have a quick look at, and the percentage of the total build cost for these and these green aspects is about 2.84%. Looking at just the green portfolio, the most recent stores, you can see that motion sensor lighting in the left-hand column is predominant, and it covers 100% of the portfolio. This was started off through construction, the idea of motion sensor lighting, and then facilities management took up the older stores and refurbished them later. I'll give you some figures on that in a later slide. You can see that once we'd reached the point of developing Kennington, construction started to put in T5 lighting, energy efficient lighting, and again this was taken up by facilities management, such that in the next few months the whole of the portfolio will be on T5 lighting. Looking at solar panels here, in the third column along, you can see that it's quite popular. It seems to be working. The ground source heat pumps we've trialled, and this is all before any government incentives to put these renewables in. We've trialled them, and there is a possibility we'll be using more ground source heat pumps for heating and cooling in the flexi offices and also in the public areas such as reception. The wind turbines are not working very well at all. They're micro wind turbines, they're in an urban environment, and they're having a lot of problems, so that's why there's only 2 ticks on the wind column. Green roofs are something that we considered. They're not economically viable necessarily, the same as rainwater harvesting, but we do put them in there either for planning permission or where we require, or we're perhaps in an area that is liable to flood. So there is some use or attenuation of the rainwater in those areas. Just looking at the 5 ground source heat pumps that we have, the average cost is about 33,000, average generation about 10,000. So we're saving about £1,000 a year at 9 pence per kilowatt hour. We estimate the return on investment of about 33 years. This is not good, but with the new renewable heat incentive scheme, the government is going to pay the difference from what you would have had to pay for a normal gas central heating, as opposed to the extra additional cost of a ground source heat pump. So the drivers in the UK for green buildings is basically the Climate Change Act, which came in on the 1st of April 2010, also referred to before as the Carbon Reduction Commitment, but they're always changing their names or having a name added onto them. It's now called the CRC and EASE, or Energy Efficiency Scheme. So this is to make us become more energy efficient, the first step that we must take. So every kilowatt hour that we can save saves us 9 pence. One of the EU directives that came in on the 1st of April 2010 as well was what we call the feed-in tariff, or it was then called the renewable cashback. But that's an incentive scheme for renewable energy. The line across the bottom there is just showing for the feed-in tariff that we can get, depending on the scale of the solar energy that we're using, 30 pence per kilowatt hour. We add in the 9 pence that we would have paid, but don't have to pay any more to the grid. And there is a deemed export. If they're small scale, then they will pay us another 50% of the amount we generate at 3 pence per kilowatt hour. So the feed-in tariff is quite generous, and it lasts for 25 years. So our green investment strategy, as of course, as mentioned before, is energy efficiency first. And the first thing we did is all the non-half-hourly meters we added smart meters to, because the half-hourly meters are fairly smart. We can get the data from them quickly, and we wanted real-time measurement of energy in kilowatt hours whenever it was required. Another thing we did is we took one example store and put a lot of sub-meters on it. I must admit that was during certification for BREEAM, which recommended that. So we took the idea, and we're analysing that data at the moment to find the exact amount of energy that each part of the store is using. So energy efficiency obviously focuses on motion sensor lighting, which we were led to believe at that time would reduce our energy by 30%. That was about 2008. The energy efficiency T5 lighting, minus 20% reduction. And LED lighting we're now installing for trials in new stores. And as quoted as before, I think I've got 70% reduction there. Someone mentioned 60%. But on top of T5 lighting, it may not be as much as that. So from the figures we've got at the moment, you can see that lighting is 65% of the storage use. And the lifts, when the store is 80% occupied, we're looking at about 23%. You can see that heating and cooling, we require slightly more cooling, 3.1% rather than 2.5%, because of the good insulation of the stores themselves and the fact that the reception area is sited within the shell of the store itself as well. The ventilation, you can see there, 1.9% is for the top floor. In the summer in the UK, it does get a little bit warm sometimes, and so the fans switch on at about 25 degrees centigrade and use up a bit of energy. It's about 3,000 kilowatt hours per year, so it's not a lot. So a typical store will use about 160, 170, maybe 200 kilowatt hours per year. And the emissions, as you can see there on this particular store, are about 70 tons of CO2 per year. So the energy efficiency starts when the customer goes to get access to the storage. It activates the lighting on the level that the customer is going to. The T5 lighting is already in place. It costs, at new build, it's costing us an extra £15,000 per store to put in the T5 lighting. And from facilities management, they're saying the return on investment is about 9 years. And the area that we're looking at the moment, we're using LED lighting externally, of course, for the signage, which is just the bottom part there, big yellow self-storage. But as I said before, we're taking this inside the building and looking for the LED providers to improve their technology and the cost of LED lighting before we go any further. At Sutton in South London, we put up our first green roof and green wall, about 500 square metres of roof, £75,000, and the average price is about £150 per square metre. I believe these are a good thing because of the urban heat island effect, again, which was mentioned before. I think they add a lot of good insulation to the roof and perhaps are delaying the fans activating in the middle of the summer. I believe we can get cooling off it because as the rain falls and the wind blows, we get evaporation. Therefore, I should think that has effect as well. Also, in these urban environments, when we have quite a lot of heavy rain, then the drains become full, they do flood, and the less hard standing we have at ground level, the better. The more landscaping we have, the better the water is allowed to drain away, and some of the water is held up at the roof level as well for a period of time, and that's where rainwater harvesting comes in also. But economically, it's very difficult to measure what the benefit is. That's the green wall when it was young, so that was taken at a sharp angle. It's much bigger now, and I'll get a new photograph later on. So it's about 55,000 about. The green wall was in fact more expensive because of the structures to hold up these little flowers was required. I'm not sure of the structural engineering that went on there. Rainwater harvesting system, about £10,000. This is Barking in East London, 750 square metres of green roof, again £150,000. The bare patches there that you can see of soil are for local seeds to sort of inhabit that area and give some kind of local foliage to that area. However, in the East End of London, our next door neighbour decided to get a caterpillar and put up some sunflower seeds on there, so we've got some quite giant sunflowers on our roof. You've got to be careful what you do in the East End of London. So here's Fulham, back to Fulham again, 280 square metres of green roof, ground source heat pump and solar panels. So moving on to the solar PV strategy, we did find that the ground source heat pumps were not warm enough in the winter, and some of our staff were complaining they couldn't get enough cooling out of them during the summer. So there is a little bit of a question mark on that technology, but I think it will work well in some of our flexi offices. Certainly, solar PV, as we were told, was the most expensive form of technology, but for us it works very well, and it's the most economical. It generates during the day when we need the electricity to have the lights on. It's carbon efficient in that we don't need any power to start, as the wind turbine does, to start up the blades and to slow them down when they get too fast. There are no moving parts. We get a reasonable supply. They meet planning conditions that are set. They're easy to monitor via data loggers and websites from the office. And there is a reasonable feed-in tariff over a 25-year period. And they're applicable to the whole portfolio. So the return on investment for small and large scale is somewhere between 10 and 15 years. And after that 10 or 15 years, it's clear profit. So the renewable strategy, we are monitoring it quite frequently, in fact on a quarterly basis, to feed that information back to the energy supplier so that they can pay us now on a quarterly basis. So this is the feed-in tariff payments, and if you look at the small scale kilowatt hours there in the first column, in kilowatt hours, it's been 4 and 10 kilowatt hours. We get paid 36.1 pence per kilowatt hour, which is a good amount. And for the larger scale, which is between 10 and 100, it's 31 pence per kilowatt hour. But 2 days ago, the new government, I think, have gone out to consultation on that figure. Most of our solar panels at the moment are about 20 kilowatt peak. But we've just found out that a lot of farms or farmers in the south of England have decided to go into solar farming and are going to soak up this feed-in tariff because they're going above, within and above the 100 kilowatt hours, and the government doesn't want the funds to run out too quickly. So what they're going to do is we've already put in planning and getting planning permission for 2 new stores with about 90 kilowatt peak. And that means now that only up to 50 kilowatt peak will be paid at the 31 pence and the remainder will be at 19 pence. So all of our figures on our return on investments are out of date. And so this is a good lesson for this conference about the drivers from government. These can change and have changed. Also, the carbon reduction commitment has changed from a carbon trading scheme and an incentive to a straight carbon tax. And I believe this has happened, these kind of incidents have happened in other countries as well. But I still think it's worth doing, but perhaps on a different scale. There may be a possibility that we can switch the larger scale solar panels and put them on 2 different meters so they look like 2 small generating sources rather than one big one. Well, we'll try that on later on. Some more examples of Spalum. These are some more examples. I'll just flick through these because you can read the actual data on here. And wind turbines which are not viable. Some of the figures that we're earning already. An example of the return on investment on a smaller solar PV. This is a model of a large-scale PV spending 2.2 million and getting a return in over 25 years of 4.8 million. Some of the benchmarking that occurs that has been mentioned before, the BREEAM, the Energy Performance Certificate across Europe, European directive is very useful. We've got Twickenham at net zero carbon, and we can rank our stores using the energy performance certificates, whether they're 2 levels above the average new build in the UK. And then some figures on some of the successes we've had. We've saved about £100,000 through carbon efficiency, and about 8,000 through renewable energy. So there is an 8.4 reduction in carbon emissions. And we're spending on green investments as a percentage of build cost about 3%, and as a percentage against revenue about 1.7. And so I will finish at that point, and just to mention some of the other organisations that we've got involved with, the Carbon Trust Standard, the Carbon Disclosure Project, FTSE for Good, and of course the Maastricht Survey as well. Thank you.